Hello, my name is Sylvie Trudel and I'm glad to present to you Module 6 of the Cosmic Early Sizing. In this module, you will learn how to estimate the functional size of software early in the life cycle. There are also topics in other modules that I invite you to view. Why should we estimate the cosmic size instead of measuring the cosmic size? Well, it is necessary to estimate the size when the quality of the documentation of the actual requirements is not sufficient to measure. It can then be estimated. So early in the project, we need a measure of the functional size to get an idea of its size for cost or effort estimation purposes. Approximated size measurement is then acceptable or even desirable because an accurate measurement would require that the functional requirements be completed. But at the early stage of the project, well, a good approximation is far better than no measurement at all. Now, if we're looking at measurement versus estimation of size, well, accurate measurement, we have obtained that at the end of development, where the cosmic method could be applied. The expected accuracy of estimation model will vary considerably across the project lifecycle. This is illustrated by this figure where it shows here what we call the cone of uncertainty that was first published by Barry Bean, where the error margin can be up to 4 orders of magnitude of what the actual effort or cost will be. At the end of the project data can be deposited in the organization data repository where the cosmic method has been applied on the size attribute of the project. But what about the feasibility study at the early phases of the life cycle? Well, we have a document called the Early Software Sizing with Cosmic Practitioner's Guide, which can take some data from our repository and apply them so we can estimate the size in the early phases of the project. That document will show and explain different techniques to approximate the size. And this is exactly what we'll view in a moment. So the approximation techniques at the requirement stage into that guide are the average size of functional processes, the fixed size classification, the equal size bands, the average size of use cases, the software iceberg analogy, and functional patterns. In the Cosmic website, there is also the Early Software Sizing with Cosmic, the expert guides, which goes deeper into those techniques, but also adds more refined, I'd say, techniques at the feasibility stage, such as the early and rapid sizing, the easy sizing, the EPCU fuzzy logic. EPCU stands for estimation of project in a context of uncertainty. And there are other methods as well. Now, in this module, the early sizing techniques that we will see are the average size of functional processes, the fixed size classification, equal size bands, average size of use cases, and early and rapid sizing. Now, first technique, average size of functional processes. From past project or from the few detailed functional user requirements of the current project, calculate the average size of a new functional process and a modified functional process. You make the list. You just have to tell which one is new, which one is modified. And then you calculate the average size of each of these. So suppose that a new functional process is 8 cosmic function point and a modified functional process is 3.5 cosmic function point. For the new project to estimate, make a list of the required new and modified functional processes, then extrapolate the size with the calculated averages. Now, suppose that your new project has 20 new functional processes of 8 cosmic function point on average. It should be 160 cosmic function point. And if you have 5 modified functional processes of an average of 3.5 cosmic function point per functional process, if we round this up, it's 18 cosmic function point for a total of 178 cosmic function point. The fixed size classification techniques, well, to apply this technique, it requires an identification of functional processes in order to classify them by size, which should be calibrated locally. Example with 3 size classes of small, medium, large. Then a small could be of 5 cosmic function point. Let's say it handles 1 primary data group. A medium one would be an average of 10 cosmic function point, where it handles its medium because it handles, let's say, 2 primary data groups. And a large one would be 15 cosmic function point, and it will handle 3 or 4 primary or major data groups. So after identifying the number of small, medium, or large functional processes in your project, you calculate the total approximated number of cosmic function points based on these fixed size classification. The third technique is the equal size bands. The application of this technique requires an identification of functional processes in order to classify them by size. Now, it's important to take a sample of precisely measured functional processes. You sort them by size, and then you divide the total size into 3 or 4 bands of equal total size. Let's take an example with 4 bands of small, medium, large, and very large. That was built using data from 34 projects in management information system. Now, the total size is 100%, and bands of equal size are divided in such a way that 25% in that case for bands is 25% of the total size is allocated to one band. So they are of equal size. For the small one, the average functional process was 4.8, and those functional processes accounted for 40% of the total number of functional processes. The medium one was 7.7 cosmic function point, represented by 26% of the functional processes. The large functional process band was 10.7 cosmic function point on average. It represented 19% of the total number of function point of functional process, and the very large 16.4 represented 15% of the number of functional processes. After identifying the number of small, medium, large, very large functional processes in your project, you then calculated the total approximated number of cosmic function points with these values. The fourth technique, average size of use cases. Well, a use case may be refined into one to several functional processes. Local calibration might determine that a locally defined use case comprises, on average, 3.5 functional processes, each functional process of an average size of 8 cosmic function points. In that case, the average size of a use case, according to this local definition, is 3.5 functional process per use case times 8 cosmic function point per functional process. Well, that's 28 cosmic function point per use case. To approximate the size of the project, you apply this average on the number of use cases. The fifth technique, which is more refined, is the early and rapid technique. Now, this grid of data has been analyzed with data from 250 different projects, but all in the management information system. We have here minimum and maximum of functional processes, small, medium, large, very large, that is similar to the fixed size classification. In that case, the most likely represent the average size of the functional processes that were categorized in each category, small, medium, large, and very large. So very large was over 14 cosmic function points. So it ranges between 14 and 30 with an average of 23.7, where the small one averages 3.9 cosmic function point, the medium one 6.9, the large one 10.5, etc. And then there's the typical process, small, medium, large, which represent what we call a CRUD or CRUD plus list. It's create, retrieve, update, delete for small and medium processes. Then this varies between 15.6 and 27.6 with an average of 20.4 cosmic function point. And then there's the medium CRUD and the large CRUD. And the typical process can be viewed per business subject. So when you do have the list of business subject and you applied CRUD on all of them, you can figure out if it's small, medium, or large and apply either the most likely value, or if you think it's on the lower end part because it's large, but it is quite simple, then maybe it's 42. For maximum value, something quite complicated, then 63 cosmic function points. The general process, that's the number of functional processes for small, medium, large. Well, this can be viewed as a module. And the macro process can be viewed at the level of the application itself. So this technique is similar to the fixed size classification. By analyzing the functional processes already measured, we get an idea of the number of functional processes we have in the project total and the size per business subject. Do we have a CRUD that is 3, 4, or 5 functional processes, or a report which is only one functional process? Here's some examples. Suppose you have only one primary data group of a small CRUD, then let's go to the low part of the interval, and that's 15.6 cosmic function point. Then you have a report that most often use more than one data group, then that's 6.9 cosmic function point. Take the average value. You have to note that for a CRUD, the expression is often manage some business subject, like manage a customer, manage a product, manage employees, manage suppliers, etc. While for a report, the expression is simply list customers, report on employees, list products, etc. So how should we select which techniques to use? Well, first, is there a list of functional processes? If yes, then the candidate techniques are the average size of functional processes, the fixed size classification, or equal size bands. Is there a meaningful sample of requirements? Meaningful means you have a certain number. If yes, then average size of functional process will be fine, or equal size bands can work well. Otherwise, fixed size classification might be a better technique. Is there only a list of use cases? If yes, then the average size of use case would be a good technique, or you can apply the early and rapid cosmic approximation at the level of typical process. Can the number of functional processes be approximated by looking at use cases? If yes, we can go back to the fixed size classification. If not, can we estimate the approximate size of the use cases, small, medium, or large? If yes, then the early and rapid cosmic approximation might be a technique to consider. If not, well, we have to estimate the size by asking whether the overall process is small, medium, or large. Let's look at an overview of the described technique, well, at least the fourth ones, for the requirement stage, with their strengths, weaknesses, and areas of application. The average functional process technique is easy to use. However, it's domain dependent and it does require sampling, and you can apply the values obtained as long as the project you're evaluating or estimating fits the one of the sample. Is the same type of applications and same type of technology. The fixed size classification is easy to use and the scaling factors are documented. It's also domain dependent, and assigning a class to a functional process is subjective. So size classification must fit the software, so it has to be carefully assigned. The equal size band, it's also an easy to use technique. More bands leads to a more accurate approximation. There is no limit in the number of bands that you define. There can be more than 4, could be 5 or more than that. If you are working with super large system with lots and lots and lots of functional processes. So functional processes needs to be classified correctly. Bands must be significantly far enough apart, and it requires a sample data set. Now, it works for business and real-time embedded for as long as your bands are defined per system type, and you will end up most probably with a skewed distribution of functional processes, which doesn't mean it's not accurate. On the contrary, if you have several bands, like 4 or even 5 bands, it will be more accurate than the first technique, but you may end up with differences due to the skewed distribution and the fact that some functional processes may not have been classified correctly. The average size of use case technique, it's easy to use when use cases are standardized. Now, functionality assigned to a use case can vary. The scaling factor is a product of 2 factors that has a certain estimation or approximation as well. So it is less precise because of that. It requires a sample data set, and it's applicable when the same your project is the same as the sample data set, and that you also have standardized use case in the way they are defined. As an exercise, with the requirement document that you know or you already have on hand, it is suggested that you use 2 techniques. A, the average size of functional processes, or B, the early and rapid cosmic approximation. Technique A will be more accurate if you have the list of functional processes. You can take inspiration from the values at the level of typical process if you only have the list of use case. For further information, you are invited to consult the Cosmic website at www.cosmic-sizing.org, and you can refer to the two guidelines mentioned earlier, where you can find detailed explanation about the techniques that we've seen, plus other techniques as well. Thank you.